Salam and hello everyone. Today we're going to be working on the question on the screen, and this is another physical chemistry question that says a vessel of volume a vessel of volume 22.4 dm cube contains 1.5 mole of H2 gas and 2.5 mole of N2 gas at 273.15 Kelvin. Calculate the mole fractions of each component, their partial pressures, and their total pressure. So the first thing you have to do is for you to basically put to write out the parameters that we're given. We have the volume to be 22.4 dm cubed, which is the same thing as 22.4 liters because dm cubed equals liters. The next thing we are given is the number of moles of the H2 gas is 1.5 mole, and the number of moles of the N2 gas is 2.5 mole, and the temperature of the vessel or temperature of the gases in the vessel is 273.15 Kelvin. So we're asked to find the mole fractions of each component. So now mole fraction is just the number of moles of the one of the components, say H2, divided by the total number of moles. So the number of moles of one of the components, for example, H2 divided by the total number of moles, so you get the mole fraction, which is just signified by or the symbolized by the cursive X and then the subscript of the symbol of the component or the gas. So XH2. So that's how you would get the mole fraction. We can also replicate this with nitrogen. But before we go on to do that, let's start with solving or by solving this. So you have the mole fraction of H2 gas to be the number of moles of H2, 1.5 mole, divided by the total number of moles, which is just the addition of both the moles of the number of moles of H2 and the number of moles of N2 gases. So you have 1.5 mole plus 2.5 mole. So basically, it's just like NH2 divided by NH2 plus N2. So that's just basically what's happening. We're adding the number of moles of N2 and H2. So XH2, the mole fraction of H2 gas is 1.5 divided by 4. So mole. We are going to cancel out number of moles because that's how we do it in chemistry to get 1.5 divided by 4, which is just simply 0.375 for the mole fraction. Now, the second one is to find the mole fraction of N2 gas. So that would be XN2, which is the number of moles of N2 gas divided by the total number of moles, or the N2 plus NH2. Just basically what we did, we're just replicating the same thing here. So number of mole of N2 gas would be 2.5 mole, okay, divided by 4.0 mole. And what we end up getting is, when we put this in the calculator, we get 0.625. So now we have both information. Now we're asked to find the partial pressures and the total pressures. Partial pressures means the second one. Now it's important for you guys to know this. Whenever you're given a question that involves partial pressures and total pressures, that means you're going to be dealing with the Dalton's law of partial pressure, which is just the total pressure of a particular mixture is the sum of the individual pressures exerted by each of the gas components. So in this case, it's going to be the total pressure equals to the partial pressure of H2 gas plus the partial pressure of N2 gas. If we had five different gases, you're just going to add up the individual pressures of the five gases to get the total pressure. So that's something you need to know. Another thing you need to understand is the partial pressure of each one of those gases divided by the total pressure would give you the mole fraction of the gas component in question. In this case, that's H2 gas. So this is another way of solving it. That means in order for us to find the partial pressure, we have to know the total pressure, or in order for us to find the total pressure, we have to know the H2 gas. But in this particular case, what we have is the mole fraction, but we don't have the total pressure, we don't have the partial pressure. So it causes a little bit of stress in the work. So what we have to do is to think outside the box and think within the information that we're given. So what we have to do in any case is to remember what we're given and what we've solved for in the question. We've been given the volume, we've been given the total number of moles by adding up the individual numbers of moles, we've been given the temperature. So this is just calling us to do the ideal gas formula to solve for the total pressure first before we can go on to solve the partial pressure. So that's going to be the total pressure equals the number of moles for all of the mixture. So the total number of moles times R times T divided by volume. Since we're solving for total pressure, we can rewrite the formula as this. And we're just going to input the information we have. Let's pick a different color. Let's do green. So PT is going to equal number of moles, total number of moles is 1.5 for 2.5. So that's 4.0 mole times 0.08206 liters ATM divided by mole Kelvin times the temperature, which we have to be 273.15 Kelvin. All of this information divided by the volume, which is 22.4 liters. So simple thing is just for us to cancel out all of the units and go on from there. So we have liters cancel liters, mole cancel mole, Kelvin cancels Kelvin. So we end up with rewriting what we have. We have PT equals 4.0 times 0.08206 times 273.15. And we have ATM. Since we're solving for pressure, let's not forget our ATM because that's like the only unit that remains, and we're supposed to get our units for pressure to be atmospheres. All of that information divided by 22.4. So input this information in the calculator to get 4.00. So pure pressure will be 4.0026, which is approximately 4.0 atmospheres, which is going to be the answer to the total pressure. Now we've gotten the first question, the mole fractions of each component as well as total pressure. Now we can do the simple math and all the formulas we've learned so far to find the partial pressures. So partial pressure, let me use a different color just because we've been overusing blue. So let's pick a color. Let's use orange. So you have the total pressure, sorry. So you have the partial pressure of H2 gas to be the mole fraction of H2 gas times the total pressure. Remember how I told you pH2 divided by P total equals the mole fraction of H2? This is how you can like do this as well. So this is basically a formula. Well, we rearrange that formula by solving everything and equating it to the partial pressure of hydrogen to get the formula that we're about to use here. So we have the pressure of hydrogen gas to be 0.375 times the total pressure of 4.0 atmosphere. So pressure of hydrogen gas is 1.50098 atmospheres, which is approximately 1.5 atmospheres. That's what we get. And remember that I explained Dalton's law of partial pressure previously to be total pressure equals the sum of the individual pressures exerted. So that would be Pn2 plus pH2. Hence, Pn2 is just going to be the total pressure minus the pressure of H2 gas that we just solved for. So that would be Pn2 is going to equal P total, which is 4.0 atmospheres, minus pH2, which is what we just solved for, 1.5 atmospheres. So Pn2 ends up being 2.5 atmospheres. So the partial pressure of nitrogen is 2.5 atmospheres. And we have come to the end of doing all of this questions. Make sure you follow me and watch the rest of the series. These are questions from the Oxford Atkins Physical Chemistry textbook. This is also the 11th edition, and I'm going to be working on solving all of the problems in different chapters of the book. I wish you guys all the very best. I hope you've understood something or more than something. Assalamu alaikum wa rahmatullahi wa barakatuh.